Okay, so hi guys, welcome back. So today we'll be solving bind 75 questions. The first question, that is contains duplicate. You can just follow this website to check your progress. This is really handy, to be honest, and you can check other resources too. I'll mention all the links in the description. So with that said, let's get started. So the question says, given an integer array nums, so we have an integer array in the parameters or arguments, that is nums, return true if any value appears at least twice in the array. That means any value or element appears more than one, we can just return true. Okay, and else return false. So this is really simple question, so I'll be sharing three approaches to solve this. So we have constraints 1 to 10 to the power 5. So nums dot length can be 1 and can be 10 to the power 5. So we know if the array size is 1, so here it says if the array size is 1, so we don't have to check anything else, right? We can just simply take we can just simply check if the num's length is 1, we can simply return false, because there is no duplicate, because we have only one element. So if nums dot length is equals 1, return false. Cool. So if we have any let's say, it will fail all because there's a reason. Yeah, and we can return directly false over here. So we can say, like, if the num's length is 1, it will return false. Yeah. So just to make things clear, this will be the ultimately we have to return false if we don't have any other cases passed, if there is no there is no duplicate element, and we have to return false if every element is distinct or every element is unique. Now the question arises is, we have more two or one edge case in the interviews. The question here, it says the constraint has the length can be uh, equal to 1 or greater to 1. So it might be the case in the interview you will be given a null array, so the array length will be 0. So we can definitely check that if nums dot length is equals 0, return false, because we don't have anything to do, so we have to return false. And we can just comment it out for a moment, because in the question there is no use to use this, but in the interviews you can definitely use this. Or you can use if the nums dot length is less than equals 1, we can return false and we don't need this. Or it is less than 2, we don't need this. Yeah, this is this looks great according to me. Yeah. So the first approach we can solve this question is, the first approach that comes to my mind is, and the first approach you should definitely say to the interviewer is, like, let's see, yeah, two for loops. So we will have two for loops. So the first for loop, that is for I range 0 to n minus 1. What is n over here? It is the length of array. And the second for loop will be for j is equals I plus 1 to n minus 1. So the second for loop will start from I is equals I plus 1 to n minus 1, because we, let's suppose the element is 1 2 3 1. So I starting from here, we can't just simply say like j start from here, because it will be ultimately equals, I is equals to j ultimately. So we have to start j from the next index to n minus 1. So I will run I to n minus 1 and j will run j to n minus 1 for the first time. For the next time I will be here and j will be here. We don't have to compare, like, suppose you might ask, like, I is here, we can start j from here. But no, we already checked in the first example, I was here and j was here, so we don't have to compare it multiple times, we already did that. So in the nested for loop, we can check if nums of I is equals nums of j, we can return true. Yeah, and if not, at the end we can return false. That's it. It's too simple. So let's do this. Okay, let's run this. So the test case is 1 over here. I'll be changing the test case. Let's see, it returns true. For the next test case, let's see what it will be returning. It passed the next test case and the last test case. It passed, and this is the last test case. Okay, we have to wait. Cool, it passed. Let's run this. So the time complexity for this approach will be O of n square, because we are looping the entire array for 2 times. Okay, so here it failed because time limit exceeded. The two for loops are taking so much time that it can't handle this much of data. Let's see how big is the data. So this is the data we are this is the test case we are actually going through, and this is a test case we didn't pass. You can see how big is the data. So this is where it fails. So let's check the second approach. So the second approach is we can definitely just sort the array. Okay, what? Okay, it's taking too much time to erase. I'm not familiar with this software actually. Okay. Okay, so the next thing will be we'll be sorting the array, and we'll be checking from the I plus 1 index. We'll be starting from the I plus 1 index, and we'll be checking if I plus 1 is equals to ith index, then just return true. Or we can just start from I plus 1 index and check the I minus 1 index. So this is how it will look like. So here's our array: 1 2 3 1. We are starting at I plus 0 plus 1, that is the first index. Okay, this is the first index: 1 2 0 1 2 3. Nice. Now here we can see like we already checked if the nums length is less than 2. That means if the array is like 1, or if the this is the array, this is the input array. Okay, if this is the input, we will just return, what will return, will return false. Cool. Now we will never face this index out of bound issue in this approach, because we have already checked if what if the case is the array size is 1 or less than 1. We will never face this because we already checked this. If that's the case, it will return false. Else we can start from the first index. So I is at 1, and we will check I minus 1 index. So this is I minus 1. Again I will go here, and this will be I minus 1. Again I will go here, and this will be I minus 1. So we have to check I and I minus 1 index. So initially I will be at the first index, and in a for loop we will start int I is equals 1, I is less than n, I plus plus. And if nums of I is equals to nums of I minus 1, that means the last index, the first index and the last index. For the second time when I will be 2, it will be the second index and the first index. and for the next time it will be the third index and the second index. So it is checking the current element and the previous element. If that's the thing, we will just return true. Let's check this. I is at 1, I minus 1, it's not the same. We will go to this part, this will be I and this will be I minus 1, it's not the same. Now again I will be at here, it's not the same. But we have the same elements over here. What we will do? Is there an approach? Previously I said the last approach was O of n square. Remember, because we were using two loops. You can even see here we are using two loops for the entire array to loop. So that is taking O of n square. So this to reduce this we'll be using sort method. Arrays dot sort nums, or array, anything in your language it will be different. So okay, so now first we will doing arrays dot sort, so it will be 1 1 2 3. Once we are done, I will be at here and this is I minus 1. Now what we'll be doing is uh, it will be checking I is equals to I minus 1. Yes, it is equals, return true. Return true, simply. Let's check the algorithm. So we have sorted the array, so the array is now 1 1 2 3. Now we'll check from index I is 1, I is less than nums dot length I plus plus. If nums of I is equals to nums of I minus 1, return true. So we are just looping for the entire array at once, and this is taking okay. So what is happening, like this one loop, the we are looping one time, right? In the algorithm we are looping one time, and this is taking O of n. This is taking O of n, and this sort method, the inbuilt sort method is definitely like either modified quick sort, that is a hybrid sorting algorithm, or tim sort, which is also an hybrid sorting algorithm, a combination of insertion sort and merge sort. So this will be taking O of n log n in all the cases, and a space of O of n. Definitely it will take space, yeah, okay. So the maximum of these two, this is the time complexity of to loop once, and this is the time complexity of looping, sorting the array. So which is the greater? Obviously n log n. So time complexity will be n log n. Now our time complexity is reduced, O of n square to O of n log n. It is reduced, but at what cost? We have got an extra space. We are using extra space of O of n just because of sorting. So let's check the solution. Let's submit it and check whether it is working or not. Cool, it worked. 24 ms, 24.19. Well, it does not matter. Please don't follow these statistics. It's great to follow statistics, but just don't believe in this stuff. You can just definitely go to the discussion section and check multiple approaches over there. So this was the first working approach. The first approach I said was a brute force approach that was not working, because we used two for loop, and for the big data set or big arrays it will not work because we are using O of n square approach. Now the third approach. So the third approach will be using hash. If you don't know hash, let me explain you. We'll be storing the data in a set that does not allows duplicates. Okay, we'll be using hash set that does not allow duplicates. It automatically removes that duplicate element, and we can also check if the set has any duplicate, or the set has that current element we are comparing with. Suppose we can compare like set dot contains that current element 1 2 3 or anything. So in that case we'll be having nums of I in the for loop. So first we will do a for loop. Just to make things simple, I can use for each loop. Okay, nums, this is for each loop if you don't know. And in this, if set dot contains I, what does this means? Okay, it will not be semicolon. If the set does not contains I, which is the current element we are looping in for each loop, just add this I. Cool. But the question arises, when we will return true, when we will return. So in that case we have to remove this uh, exclamatory mark, because we can easily check if the set already contains the element. If this is my array, I have added this, done. I have added this, done. I have added this, done. But in this case, I is at 1, I is equals to 1, and 1 is already in my set. 1 is already in my set, I will return true. Else, I can just add that current element, which is not in the set, I will add it. I don't have to use else if. I have to use if, but I don't have, you have to use else. It will automatically add this if this statement is not true. So let's try this. Okay, let me discuss the time complexity and the space complexity. Well, hash set will use your O of n at worst case and also the best case, and we are also looping once, so the time complexity is O of n. So this is also the time complexity, this is the space complexity. You can see initially it was O of n square, and it reduced to O of n log n with a cost of space complexity of O of n, and again n log n is reduced to, sorry, again n log n is reduced to O of n, which is really a great approach. We have to loop the array only at once, and the space complexity is same, O of n. So let's code it out. We can use set interface. Let's run this. Yeah, it works great. Let's submit. 6 ms. It's working great, better than the last one, 73 MB, 54 MB. It's working great. So these are the three approaches I discussed, from among which one was not working just because the data set was really big. So you can just follow these steps I mentioned below. I can just drop the codes of all the approaches in the description if you want, uh, or you can just join my Discord channel. I'll be sharing the link in the description. You can just check the codes out over there. And yeah, on also you can also check the codes over here. You can just click on this and you will get the entire solution over here. And yeah, that's it. That's all for this video, and see you guys in the next one. Till then, peace, bye, take care.